We have 3 over 7 plus 5 over 2. So let's begin. So the first step would be to highlight 3 and 2, this diagonal right here in red. And then we take the diagonal 7 and 5, this diagonal here. Then we multiply 3 times 2 and we get 6. Then we multiply 7 times 5 and we get 35. Next, we multiply 7 times 2 and get 14. So we're taking this diagonal here, 3 times 2, and get 6, and this diagonal here, 7 times 5, to get 35, and then the bottom, 7 times 2, to get 14. Next, we add the top part, 6 plus 35, and we would get 41. The bottom part remains the same, 7 times 2 is 14. So we get 41 over 14 would be the final answer for 3 over 7 plus 5 over 2. Now we'll do subtraction. 6 over 5 minus 4 over 3. Same exact procedure. So we take this diagonal here in red, 6 times 3, and we take this diagonal, 5 times 4. So 6 times 3 is 18. 5 times 4 is 20. And then we do the bottom. 5 times 3 is 15. Now this part is a little different because it is subtraction. We move the subtraction sign to the top. 18 minus 20 is negative 2. 5 times 3 is the same, 15. So the final answer will be negative 2 over 15. And that is the butterfly method for fractions whenever we're dealing with addition or subtraction.
Let's look at these two fractions, 1/8 and 3/8. Because these already have the same denominator, all we have to do is add the numerators. 1 plus 3 is 4, so we get 4/8. It's important to note that when adding fractions, we do not add the denominators. Just like we would say 1 apple plus 3 apples equals 4 apples, the same logic applies here. We can imagine an eighth as a slice of pizza, and 1 slice plus 3 slices equals 4 slices. The denominator reports the magnitude of the fraction, so this won't change as we add and subtract. Once we have the sum, we can reduce if applicable. 4/8 reduces to 1/2, which makes sense as 4 slices is half a pizza. So that will be our final answer. What if the fractions do not have the same denominator? In that case, we have to change them so that they do have the same denominator. But if we recognize that the least common multiple of 3 and 4 is 12, then we can make things easier for ourselves. Multiplying by 4 over 4, 1/3 will become 4/12, and multiplying by 3 over 3, 1/4 will become 3/12. Now we just add them together, and 4 plus 3 is 7, so we get 7/12. For subtraction, it's essentially the same thing. What if we had 1/3 minus 1/4? Then we would just change that to be 4/12 minus 3/12. We just do 4 minus 3, and we are left with 1/12. How about a trickier one, 1/5 plus 2/11? Well, the least common multiple of 5 and 11 is their product, 55. So let's multiply by 11 over 11 and 5 over 5, which will change these to 11 over 55 and 10 over 55. That gives us 21 over 55, and that's all there is to it. Now try 2/7 minus 3/5. The least common multiple is 35, so this will become 10 over 35 minus 21 over 35, giving us negative 11 over 35.
Let's see how to add 3/4 to 1/6. We're going to do this using a 3-step method. The first step, which we call step 1, is to find the least common multiple of the two denominators that we have. In this case, the denominators are 4 and 6. In other words, we have to find the least common multiple of 4 and 6, which we write LCM 4, 6. To do this, one of the easiest methods is simply to write the multiples of 4, which I'm writing here, 4, 8, 12, 16, etc., 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 as well as the multiples of 6, which we can write here. That's 6, 12, 18, 24, and so on and so forth. Now, looking at these two lists, we can see that the least common multiple is clearly 12. And so we can write below LCM of 4 and 6 is equal to 12. And that's our first step done. The second step of this method is to express both fractions as fractions over 12. In other words, we have to express both fractions over the least common multiple that we found in step 1. Now, to do this, remember, our first fraction was 3/4. To do this, we can see that to get from 4 to 12, looking at our list here, we can see that 12 is the third multiple of 4. In other words, what we have to do is multiply 4 by 3. So I write that. But now that I've done that, I have to multiply the numerator by 3 as well. And so 3/4 is equal to 9 over 12. In a similar way, we have to express 1 over 6 as a fraction over 12. And looking back at our list here, that we found in step 1, we can see that 12 is the second multiple of 6. This means that to get from 6 to 12, we simply have to multiply 6 by 2. And again, because I'm multiplying the denominator by 2, I have to multiply the numerator by 2 as well. And so 1 over 6 is equal to 2 over 12. We now move on to the third and final step, which we write step 3. And this involves simply adding the two fractions. This is really the final one. Following what we just saw in step 2, we can see that 3/4 plus 1 over 6 is the same thing, so it's equal to 9 over 12 plus 2 over 12. Because both of these fractions are now written over the same denominator, we can add them simply by adding their numerators together. And so we can write 9 plus 2 over 12. Finally, this leads us to our answer. That's equal to 11 over 12. And we're done.
The LCM method. Let's use an example to explain it. Find 3 over 10 plus 1 over 15. Step 1. Find the LCM of denominators, or LCD. Your first step in the LCM method is to find the LCM of the denominators. The LCM of the denominators is what is called LCD, meaning lowest common denominator. So we will find the LCM of 10 and 15. You can use any of the methods we used in our video on multiples. The multiples of 10 are 10, 20, 30, 40, and so on. The multiples of 15 are 15, 30, 45, and so on. You will notice that the least common multiple is 30, which will also be the least common denominator. Step 2. Converting the numerators by multiplying. Our next step is to find what number multiplied by the first denominator gives the LCD. We know that the number is 3. 3 multiplies 10 to give 30. We multiply the numerator by the 3. So we did 3 times 3. This equals 9. We do the same for the second fraction. We find out what number multiplied by 15 will give the LCD. We know that the number is 2. We multiply the numerator, which is 1, by the 2 to get 2. Step 3. Solving by simply adding or subtracting. We can now add the numerators. 9 plus 2 to get 11. Our final answer is therefore 11 over 30. Example 2. We want to visit our first question, but then find the LCD as usual. Multiples of 3 are 3, 6, 9, 12, 15, and so on. Multiples of 4 are 4, 8, 12, 16, and so on. Multiples of 6 are 6, 12, 18, and so on. Here we notice that the LCD is 12. We move on to step 2. 3 times what number gives 12? The number is 4. Multiply 2 by the 4 to get 8. 4 times what number gives 12? The number is 3. Multiply 1 by the 3 to get 3. Finally, 6 times what number gives 12? The number is 2. Multiply 2 by the 2 to get 4. We now move on to our final step. We have 8 plus 3 minus 4. This gives us 7. So our final answer is 7 over 12.
We'll put the 1 whole as a benchmark to see if our sum is less than 1 or greater than 1. Now let's put the 1/2 strip and the 1/5 strip next to each other. To find the common denominator, we're going to use multiples. Let's list the multiples of 2. 2, 4, 6, 8, 10, and so on. Now let's list the multiples of 5. 5, 10. As you can see, both lists have 10. So 10 is our common denominator. This means that we'll use the strips with 10 in the denominator. Now we line up the 1/10 strips under the 1/2. 1, 2, 3, 4, 5. So 1/2 is equal to 5/10. Now we'll line up the 1/10 under the 1/5. 1, 2. So 1/5 is equal to 2/10. Add up the 1/10 strips. We have 7/10 strips. So 1/2 plus 1/5 equals 7/10. 1/4 plus 2/3. We're going to use 1 as a benchmark. Now let's put together our strips. We'll put 1/4. To make 2/3, we're going to use 2 strips of 1/3. To find the common denominator, we're going to use multiples. First, we find the multiples of 4. 4, 8, 12, 16, and so on. Now let's write out the multiples of 3. We're going to keep writing them until we find a common multiple with 4. 3, 6, 9, 12. As you can see, 12 is the common multiple. Now we're going to use fraction strips with 12 in the denominator. Under 1/4, we can fit 3 strips of 12ths. So 1/4 is equal to 3 over 12. Under 2/3, we can fit 8 strips of 12ths. So 2/3 is equivalent to 8 over 12. Now we add up the 12ths. We have 11 12ths. So 1/4 plus 2/3 equals 11 over 12.
Let's see, Alice made a pie and cut it up into 6 equal pieces. She gave Peter and Jan 2 pieces and put the rest away for later. How much did she put away for later? Okay, so it's basically asking, this 1 represents 1 whole pie right here, and we're going to take away, since it was cut up into 6 equal pieces, we took away 2 of the 6 pieces right there. So how much pie did Alice begin with? Okay, well, she began with 1 whole pie. Okay, and then I'm going to, how many slices are in the whole pie? Remember, it says 6 equal pieces, so let's go ahead and slice that guy up into 6 equal pieces right there. Okay, and then how many slices were taken? Well, there were 2 slices that were taken. So another way is to use fraction strips, you guys. So here's a fraction strip of, this is 1 unit to represent the 1 whole pie, and since she cut it up into 6, then I cut this fraction unit up into 6 size pieces right here. So we're going to use 1 6 size parts to model the whole pie right here. Okay, so how many 6 size parts should you cross out to model the piece that Alice gave to Peter and Jan? Well, she gave a piece to each, so there would be 2 pieces right there. Notice I crossed off these 2 pieces right there. All right, so how many six-sized parts are left? Well, there's 1, 2, 3, 4. So there's 4 six-sized pieces left. 1 six-sized piece is left. So write the difference, okay? So 1 whole pie minus, this one's going to be 2 out of 6 right here. So this 1 whole pie is actually, this should be 6 out of 6 is 1 whole pie, minus 2 out of 6 is going to equal 4 out of 6, okay? You guys see this? Can you see that 1 equals 6 out of 6? It's 6, 6 pie right there, and we take away the 2 6 pieces, and we're left with 4 6. Okay? So that's the way how we can subtract.
How about we do some work adding fractions using rectangle models? Here we go. Each model represents each fraction. The first one, I'm going to draw horizontal lines to represent 1/3. So I split the rectangle into 3 pieces, and I'm shading in one of those 3. So if you're keeping score at home, we use the denominator to show how many pieces this fraction has, how many parts of the whole, and we shade in the numerator, that many pieces. Okay, the second fraction, let's make vertical lines. We've got 5 pieces. Don't worry, I won't do this every time. And we're going to shade 3 of them. This just gives us a visual representation of what's going on here. And it's important that the rectangles are the same size, so we know that the whole is the same thing. It makes it just easier visually. Okay, so I have 1/3, I have 3/5. Here's where the magic happens. It's crazy. Okay, we take what we started with and we do the exact same thing. No, that's not the magic. Wait for it. Then we're going to take the lines, the number of divisions of the whole of the second fraction, we're going to bring those down here into the first. Bam! There's the magic. Okay, now what we have here is a new name for the same old fraction, right? It's the same thing we had above because we brought the same down, we colored it, everything's the same, but now we're renaming it because we have 5 pieces out of 15 pieces now. Okay? I bet you can guess what's going to happen, and you're absolutely right. We're going to bring the second fraction down, 5 pieces, shading in 3 of them. Identical, right? Would you agree with me? These are the same. Now we're going to take the lines that we had in that first fraction and use them to divide the second fraction into 3 pieces. So once again, we have a new name. 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 15. We have a new name for the same fraction. And that's really what a common denominator does, is it gives the same old fractions new names. Now they have the same denominator, the same number of pieces, makes it easier to add. When I'm adding using these models, I only need 1 to hold the answer, or the sum, to use technical lingo. So I'm going to draw my thirds, my fifths, and I'm literally going to take 1, 2, 3, 4, 5 of those. 2, 3, 4, 5 into there. And I'm taking 9 into there. And it doesn't matter where they go, the total will be the same. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Now my total is 14 15ths. Let me scoot it up there. Bam! 14 out of 15, and I've used the word bam twice in this video. That is my quota. I will not use it again. So that's how you add using rectangle models. Tell you what, I'm going to give you a practice problem. I'd like you to pause the video, go ahead and do the practice problem. Then when you unpause it, I will go over the answer with you. Let's see how this works. Say goodbye to this problem. Hope you took good notes.